Welcome everyone. I hope everybody is healthy and fine. This lecture starts discussing basic trigonometry. And when I say basic trigonometry, I mean trigonometry that deals with right angle triangles only and not dealing with oblique triangles. Okay, so we'll be discussing only right angle triangles in this section. And trigonometry, obviously, is a branch of mathematics that discusses triangles. Trigonometry, if you want to translate the word by word, tri, means three. Gono or gono means angle in Latin, and metri comes from the word measurement. So it means that if you translate it, it would be triangle measurement, basically. That's the name where it's coming from. But it's a branch of mathematics that discusses relationships among the three angles and three sides of a triangle, any kind of triangle. So we're starting with a right angle triangle. As I said, I have already drawn a right angle triangle. We know that we use capital letters to denote the vertices and the angles in any triangle. So you see I'm using capital letters here. This is angle A, angle C, which is the right angle, that's 90 degrees, and angle B at the corner. And we use letters, lowercase letters, to represent side lengths. This is a universal convention. Wherever in the world, Japan, China, I don't know, Middle East, South America, wherever you go, this is the universal convention. When you write lowercase b, people understand you talk about side length. When you write capital B, people think, okay, you're mentioning an angle somewhere. Okay, so now in this triangle, we have only three sides, obviously. Two sides, two legs of the right angle triangle, and one hypotenuse, right? And we have three ratios here we want to discuss. One ratio is ratio of side A to side C. In other words, side BC over side AB. Now, if you look at angle A, the side opposite angle A is side BC, which, as I said, is denoted by lowercase a. And AB is the hypotenuse, denoted by lowercase c. So this ratio of opposite side over hypotenuse, opposite to angle A, is defined as sine of angle A. So I'm going to write down here sine of angle A. The name is sine, the symbol is sin, S-I-N. I repeat, the name is sine, but the symbol is S-I-N. So we read this as sine of angle A, and that is nothing but the ratio of two sides. What two sides? Opposite side over hypotenuse, period. Now, because top and bottom are both side lengths, end of the day, both measured in centimeters or meters, so the ratio would be dimensionless, which means that sine of angle A does not have any unit of measurement like dollars or kilograms or centimeters, okay? Sine of angle A is nothing and nothing but a simple ratio. Ratio of what to what? Ratio of opposite side over hypotenuse, period, done. Now, instead of picking the opposite, dividing it by the hypotenuse, you may pick the adjacent side, which is right beside angle A, and then divide it by hypotenuse. So I'm talking about the ratio of B over C, or adjacent side over hypotenuse. Well, we have to give another name to this ratio. We don't call it sine anymore. We call it cosine of angle A. So the name is cosine, and the symbol is COS. So cosine of angle A is equal to the ratio of adjacent side over hypotenuse. These are just definitions, not a big deal. Just like I tell you, okay, this is a marker. It's a definition. Or if I have an apple in my house, okay, this is an apple, you know. And finally, we discussed the ratio of opposite over hypotenuse, adjacent over hypotenuse. The last ratio left would be, logically speaking, the ratio of opposite side over the adjacent, that is A over B. In other words, side BC over side AC. This ratio has obviously a new name. We can't call it sine or cosine. We call it tangent. So tangent of angle A is that ratio of opposite over adjacent side. So the name is tangent, but the symbol is tan, T-A-N, okay? So these three are called three primary trigonometric ratios, sine, cosine, tan. Other than these three definitions, we have one very famous formula that comes from grade 7, grade 8. It's called Pythagorean theorem. and that says that the sum of the squares of the two legs in a right-angled triangle, that is a squared plus b squared, is equal to the square of the hypotenuse, which is c squared. You have to always make sure that the hypotenuse is on the other side. So these are formulas that we'll be using in this unit, and these are all valid in right-angled triangles. I keep repeating, right-angled triangles. We will not talk about other types of triangles because we're discussing basic trigonometry. When we're done with this unit, we start advanced trigonometry. Yes, then we're going to be talking about any triangle, you name it. But so far, everything starts from basics. Now, these definitions, for the first time when you see them, it's sort of hard for you to remember. So I'm going to show you an acronym, just like the FOIL we had in algebra. Do you remember the FOIL acronym, FOIL, which helped you to remember the order of multiplying terms when you multiply two binomials? So this acronym is meaningless, to tell you the truth. It doesn't have any meaning, to tell you the truth. It's called SOHCAHTOA. You may say it's Chinese or something. I don't know. I don't know what language that is, But it is SOHCAHTOA. It's an acronym that reminds you of these definitions so that you just remember them, okay? So S stands for sine. Now watch here. Sine. O stands for opposite. H stands for hypotenuse. So that reminds you of sine is the ratio of opposite over hypotenuse. And then CAH stands for cosine adjacent hypotenuse. So that reminds you of that cosine, C stands for cosine, is the ratio of adjacent over hypotenuse. And then we have tangent, which is the ratio of opposite over adjacent, TOA. Okay, that's so-called TOA, part of this weird acronym. So SOHCAHTOA is just an acronym that helps you to remember all these definitions without, having a hard time memorizing them. Now that we learned about basic definitions, now we're going to see, how we apply them. In this example here at the corner, we have a right-angled triangle, ABC, and the angle B is given to be 67 degrees, okay? And we want to find sine of angle 67 degrees, which means that we are basically finding the ratio of opposite side, which is B, I already wrote it here, to the hypotenuse C, that ratio, okay? So now we need a calculator, and on the calculator, you make sure that your calculator is in the degree mode, and you punch in sine, and then 67 degrees. Some calculators, different models, you have to punch in the angle first, 67, and then you press the sine button on the calculator. But some other models are working the other way. You have to press sine first, and then 67. So sine of 67 degrees, if you use a calculator, I have a calculator here, and when I punch in the button, I get this answer 0.920 and then 5. And you can write like 10 digits after decimal point, because I hope you're getting this answer on the screen of your calculator as I speak, but you don't need to write all those digits. If you want, you can write it. Nothing is wrong with that. But the thing is that up to 4 digits after decimal point accuracy is good enough for our purposes, okay? 4 digits after decimal point, good enough. You want to include 5 digits, 6 digits, 7 digits, 10 digits, that's totally fine. But you can't just include only 1 digit. You can't say sine of 67 is 0.9, because, it might not be very accurate enough in doing some questions. So I say, if you agree, we can have this convention today, that we can always, go by 4 digits after decimal point. So the ratio of opposite side over hypotenuse is actually 0.9205, rounded to the nearest fourth digit after decimal point. Now we have to find the cosine of 67 degree angle. So this time you're going to press the cos button, COS, and then 67 degrees, and we're going to see what that ratio is equal to. I hope you got this answer, 0.3907. The next digit was 3, so I just rounded it down to 7. But if it was like 9, I would just put 0.8 as my last 2 digits. So I just rounded it to the nearest fourth digit after decimal point, to the nearest 10,000, you can say, okay? Now, the last one is the ratio of opposite side B over adjacent side A, okay? And you press the 10 button on the calculator this time, and you make sure that your calculator's in the degree mode, because if not, you get different answers. So I get 2.35, and then I get another 5, and then I get 8.5, which I rounded off to 9, if you don't mind. All right? So that means that 10 of 67 is 2.3559. That's the ratio of the opposite side to adjacent side. And we see that the opposite side is larger than the adjacent side, because B is larger than A, so it makes sense that it's like more than twice the size of A. Size of side B makes sense that it's more than twice the size of size A. So that's what we did. Now, the other angle, angle A, here, we can find its measure because we have 90 degrees, we have 67. The sum of the interior angles in any triangle is 180 degrees. Everybody walking on the streets nowadays knows that, okay? Everybody knows. 67 plus 90 plus angle A is equal to 180 degrees. Sum of the interior angles in any triangle. Now, to find the measure of angle A, I'm going to say angle A is 180, okay? Take away 90 and take away 67 degrees. And that will be 23 degrees using mental math, all right? That's correct. Angle A is 23 degrees. So now I want to find sine of 23 degree angle this time, okay? So sine of 23, I'm talking about angle A this time. So the opposite side will be different, because opposite to angle A is side BC. It's not like side AC as we said before when we were considering angle B. So when we say opposite adjacent, it depends on what angle you're talking about. If you're talking about angle A, the opposite side would be side BC. When you talk about angle B, the opposite side would be side AC. These are little things you have to pay attention, and it makes sense. It's like common sense kind of thing. So sine of 23. So I press the button on the calculator to see what sine of 23 degree angle is. I get 0.3907. Okay. And then I'm going to find cosine of 23 degree angle. And that will be 0.9205. Use the calculator. And then tangent of 23 degree angle. Using a calculator, we find out what tan of 23 is, and that is 0.424, and then I go 5 because at 47 I rounded up to 5. Okay, so now another thing you might have noticed here, just a side note, what I'm saying right now is a side note, okay, and that is you might have noticed that sine of 67 was matching with cosine of 23. You see that here? Cosine of 23 and sine of 67, they're matching, okay? And also, cos of 67 matches with sine of 23. So this is a side note. Some people don't know about it, but I'll tell you. And that is when two angles are complementary angles, which means that they add up to 90 degrees, then sine of one angle equals to the cosine of the other angle, vice versa. So sine of 67 is the same as cosine of 23. And cosine of 67 is the same as sine of 23. Why? Because 67 and 23 are complementary angles. You may say, okay, 1 degree and 89 degrees are also complementary angles, aren't they? They add up to 190 degrees, right? So you can use the calculator. You can try it right now if you feel like it. Punch in sine of 1 degree and punch in cosine of 89 degrees. I bet $100 that you will get exactly the same answer. Why? Because 1 degree and 89 degrees are complementary angles. So sine and cosine of complementary angles are equal, okay? You can pick any angle you want, 30 degrees. Punch in sine of 30 degrees. It's 0.5, isn't it? Okay? And now punching cosine of 60 degrees. Again, you will see it's 0.5. This is not a coincidence. This is because there's this property that when two angles are complementary, they add up to 90 degrees. Sine of one is equal to cosine of the other. This was just a side note. Okay, so we learned how to find sine, cosine using the calculator. Now, in this next exercise, we have two dimensions. We know side AC is 2 centimeters, hypotenuse is 5.39 centimeters. They're both given. We know that sine of angle B is the ratio of opposite over hypotenuse. So I'm going to write here opposite side is 2, hypotenuse is 5.39, right? So I just divide them using a calculator. And I think the answer would be, if you divide, it would be 0.37105755139. This time I wrote all of them, although I didn't have to, but I wrote all of them. Now watch here, this is important. This is important. Why is this important? What am I going to say? Because we are trying to find angle B this time. All right? We don't want to find sine of angle B. We already know the sine of angle B. It's like 0.37 right there. But we want to find the measure of angle B itself. Therefore, we are going to use the inverse sign and pressing the inverse button on the calculator. And the symbol looks like this. Inverse sine of 0.37105, whatever the number is. And on the calculator, you have to press the shift button or the inverse button or the red button, whatever that is, depending on the model of calculator you're using. And then you press the sign. So that is inverse sine of this number. And that gives you the measure of the angle, which would be 22 degrees. If you round it to the nearest degree, it would be 22 degrees. Okay? We are rounding to the nearest degree. Okay? But it could be like 21.9 degree, whatever. But I just rounded it to the nearest degree. So whenever you have the angle, like 67, you press the sine button, you find the sine of 67. That was easy. You pressed the button on the calculator, didn't you? Now, this time, whenever you have the answer for the sine of the angle, and you want to work backwards, and you want to find the measure of angle itself, this time you press the inverse sine button on the calculator, which is the inverse key or the shift button you press, okay? So inverse sine of 0.37105 is equal to 22 degrees, and that is the measure of angle B. That's how we find it, all right? Now, needless to say, if you are given cosine of an angle, let's say cosine of an angle is 0.5, let's say, okay? You want to find angle B. This time you press the inverse cosine of 0.5, and when you use this on the calculator, the answer is, of course, 30 degrees. Oh, sorry, 60 degrees, right? The answer is 60 degrees, okay? Angle B equals 60 degrees. Or, for example, tangent of some angle, whatever angle, is equal to, let's say, 1, okay? Then angle B would be inverse tan of 1, which is 45 degrees, okay? So you get 45 degrees on the screen of the calculator. Inverse tan of 1. You press the shift button or the inverse key, and then you press tan. That gives you inverse tan of 1, and that gives you 45 degrees, which means that if you punch in tan of 45, it would give you 1, of course, as the answer, okay? So I'll give you more examples in the next lectures. Thank you.